So we can just go as long, ask as many questions. So, right, so I'll introduce myself a little bit. So, Darren Shepard, I'm a co-founder and chief architect at Rancher Labs. So, if you follow like Docker community or whatever, you might see me occasionally. I built the cloud, and I got that funny little logo. So, I'm very actively involved in the kind of the Docker ecosystem. Working on various aspects of it. So if you have questions just kind of in general about Docker and what's going on, various projects and stuff, I have a good amount of knowledge in various different companies, what they're doing. But in general, and you can also find me on free now, Darren Zero. So our company, Rancher Labs, we got going about we formed the company October last year. We really ramped up development at the beginning of this year. So most of the products, like what we talked about, it's all alpha, pretty early stuff. It's not really even like feature complete in certain things. So it's like, maybe I should turn on the slide. Right. So we just started getting going. We're decent size. We're pretty well funded. So. We've got quite a bit of people working on this, but pretty much our goal as a company is we really just want to run a Docker infrastructure like at scale. The other co-founders and I, all of us have a background in infrastructure orchestration, basically the IaaS market. The other three co-founders created Cloud.com. They built CloudStack, which was eventually acquired by Citrix, and that is like the virtual machine world. If you've heard of OpenStack, it's a very simple thing. So basically we kind of come from a background in infrastructure orchestration. Before people were looking at virtual machines as their workload, now they've kind of workloads moved to containers. So we're basically just building solutions around managing containers at large scale. So we're very, very pragmatic on how we do things. We very much care about production, actually really running these things. And we have a good amount of experience in running some pretty large clouds. So before I go too much into this, just kind of curious, what's everyone's experience level with Docker? How many people have at least heard of Docker? Okay, are you guys daily users of Docker? No. Okay. And have you heard of CoreOS by any chance? Used CoreOS? A little bit. Okay. That'll kind of give me an idea. Okay, so I will. Yes, just if you have any random questions, because what we're done with RancherOS ends up being really geeky technical stuff with Docker. It's a really advanced use case of Docker, but it's worked out pretty well. But so if it doesn't make sense or whatever, just stop me, ask questions. So at Rancher, basically we have two products: RancherOS and then Rancher. So Rancher is our higher level orchestration that pulls together everything. But RancherOS, we actually just launched this a little over a month ago. I think it was maybe five weeks ago. So we just launched this, and it's a tiny Linux distribution that's its sole purpose is for running Docker. That's the entire purpose of it. So it falls in the same category of CoreOS and these other micro distributions. So it's CoreOS, Ubuntu Snappy, Red Atomic, and then now RancherOS. And there's very good indication that there probably will be more to come because these things are really kind of taking on this idea. Yeah.
So I do have a question about what you're doing with RancherOS, similar to what Fusion did with their base image. The Fusion base image?
Yeah.
So they say this is the right way to set up a Docker container. Is that how you're? I guess RancherOS isn't targeted towards that, but.
Well, yeah. So one of the things though is so basically we are focused on just running Docker, and we're really and you'll see this as we get into the way we've structured Rancher, which is our orchestration stack. We're very non-opinionated when it comes to how you run Docker. Docker is very flexible. You can do it in all these kind of backwards, weird ways. People have ideas what the right way or the wrong way to run it. I have my own opinions, but basically we don't really force anything. So there's different, there's different stacks that are built on top of Docker, let's say Panamax or OpenShift or Kubernetes, and they kind of put a certain spin on it of this is a PaaS or whatever. The way we do things is just very kind of open. So RancherOS, you want to use with like the fusion based image type approach, that's fine. One of our kind of like objectives as a company though is like, when you look at that fusion image, it's like there's very practical reasons why they did that. But it would be nice if you didn't have to. And so we try to address a lot of those things, like to make it so you don't actually have to run like, fatter containers. So you can keep a container just down to like 1 hour. It's like some of the things we've done around that. It's like in Docker 1.6, we added like a syslog log driver, and we tried to get a log rotation, things like that in there. That one, probably in Docker 1.7. But there's other things like supervising processes and stuff. There's some interesting ways we can handle the kind of the bit one zombie issue in RancherOS. But yeah, so those are some of the things like that we're working on. Okay. So it's like if you compare like RancherOS to like the other like micro distributions, it's like you start off with like Ubuntu Snappy. Ubuntu Snappy, like its origin is really from mobile, like their mobile product, and so it's actually very oriented towards application delivery. Honestly, I'm not seeing like a huge amount of adoption, and I haven't spent a lot of time with it, so I can't really like give like a fair analysis around it. But like their big thing is like the Snappy, which is application delivery, but it's kind of a weird thing because it delivers Docker, and then Docker does everything else, so you don't really use Snappy that very much. So the other one, Rel Atomic, is it's like, why would you use Rel Atomic? It's really pretty straightforward. If you want to use Rel binaries, because you're paying Rel for support, you want to use their kernel, their binaries, and basically Rel Atomic is the right answer for you. And so that's basically why they created Rel Atomic. Rel Atomic is kind of like an answer to CoreOS is really the first one in this space, and they came up with these micro distributions, and like there's various reasons why you care about these micro distributions. Is like one, they just shrink the kind of the base of the OS down, so it's kind of less things for you to worry about, less things for you to care. There's really no moving parts to it, so there's really almost nothing to maintain. So the OS becomes very small, and then when you want to get updates to it, you deliver the OS as like a whole another image. So it's like you have like version 1, then you deliver like the new version 2, it's an image, you just kind of swap over to the new image. If that doesn't work, fall back to the old one. And basically all of the RancherOS, CoreOS, Snappy, Rel Atomic, all of them follow a very similar concept of you just these kind of atomic upgrades. You can just upgrade, roll back, and then like very little maintenance or whatever. And so the Rel Atomic is basically, well, how can we take that approach and apply it to Rel? So it's actually really quite clever, the stuff that they've done. So RancherOS, basically, we kind of take everything a little bit farther than the rest of the distributions of saying like, we just care about getting Docker up and running. Once we have Docker, we can do pretty much anything. And this is kind of like our experience as we've built various products and things, and I've been working in the Docker space for like 1.5 years now, which, relatively long given that Docker's been out for 2 years. But everything that I've built, I've kind of gone for the approach like, let me try to Dockerize every aspect of it. So like when you look at like deploying, let's say like a orchestration system, a lot of people say it's like, okay, install all these things on host, and then that will allow you to deploy containers. But the approach that I took from the very beginning was like, even the orchestration systems are going to be Dockerized themselves, which is like this weird levels of inception and everything, but it forced me to kind of figure out all these different ways to deploy and run software in Docker. And basically we got to the point that it's like, well, Docker runs anywhere. Docker can run anywhere basically because Linux runs anywhere, it's ubiquitous. So all I really care about now, because I can run pretty much anything in Docker, is just getting Docker up and running. So when we started looking at RancherOS, it's like, well, what's the bare minimum we need to just get Docker up? Like, what's the easiest thing we can do? And so the first thing was like, well, like we'll just create like a BusyBox image and put Docker in there. It's like, that's very close to what boot to Docker is. If you're familiar with boot to Docker. But we're like, well, we had like the idea, we're like, well, we can actually like take it a little bit further and put the Docker is actually PID 1. So there really is absolute, like it's a Linux kernel and then Docker running on top of it. And that's basically the end result of what we're doing. let me talk a little bit more about like just kind of like some of the motivations behind this, and then we'll get into like some demoing. I think I have one more slide for this. Basically, we just kind of have this idea: is like, what if we Dockerize the entire OS, like not just your user, like your Node.js app or your PHP app, like the entire whole thing. Like, what would happen? Basically, the OS would become extremely small because all we care about is basically all we care about is Linux, Docker, and then a little bit of glue code to make it work. So that ends up being very small. It's about 20 megabytes. I think right now it's really like 24, but we'll probably shrink it. You know, it's like half of that's the kernel and all the modules. So we wanted to make it so like everything, like, you know, if you're managing every aspect of it as a Docker container, then you should be able to do upgrades with Docker. You should be able to, you know, it's like all the tools you use for Docker, you should be able to manage the OS the same way. So it's like we should just be able to say like Docker run, and then now you have like a new thing, like, you know, you can install some, let's say like ACPID, like, you know, that's a thing to manage ACPI events. Something like that, you know, can we run it in a container? The last thing is like, or no, there's one more. But we could swap kernels and consoles and just about anything. Like, one of the interesting things about RancherOS is we're not opinionated about the Linux kernel. Like, some people really care about the kernel, some people don't. Some people are just like, whatever, I just need a random kernel. Some people are like, I want a Red Hat one, or a CentOS one, or I want an Ubuntu one, or I want this like highly optimized one that I ran through a CPU profiler. Like, there's some really cool things you can do with the kernel. You run it like under a, you run it and it takes profiling information, and then you recompile it with that profiling information and optimize the kernel. Google this, stuff like that. But so, RancherOS, all we really care about is Docker. Like, Docker is kind of like our layer that gives us, you know, it's like kind of the guarantees of the runtime. So what's below it is a Linux kernel, so we don't care a lot about that specific kernel that we're on. So what we'll actually be doing in the future with RancherOS is allowing you to very easily swap out kernels, because people care about, like in the hosting world, you'll care about like a GR set kernel. So we'll make it easy for you to do that. But even like the console you can swap out, and like I'll talk about that later. I'll show you like what that really means. And like the last thing is, this is the stuff that like we're working on right now. Like, we'll probably release this week, but then next week we'll be showing a bunch of examples of how to use it. But you know, if your operating system is just a series of containers, you can use Docker Compose to describe the entire operating system. And so if you're not familiar with Docker Compose is like basically a way, like if I have an application which is like, it's a web tier, an app tier, and a database, maybe some worker nodes or something like that. Compose, you can describe the whole thing, and then just say like compose up, and it just deploys the whole thing. And so basically we've taken that compose syntax to describe the operating system. And I'll show you all that. So going back to like kind of the technical details, so at the very bottom, so we have a Linux kernel, and right above that is a PID1, which is what we call system Docker. So system Docker comes up and it launches all the system services. So like we just, in a Linux box, you need some generic things like UDEV is important, plugs all the devices and stuff like that. So you need UDEV running, you know, a DHCP or NTP, syslog, you know, things like that, you know, you need running. So system Docker handles all those system containers. And then there's one special system container, which we call user Docker, which we actually launch another instance of Docker. So it's kind of Docker and Docker. And the user Docker is the one that you actually use to deploy most of your containers. But we separate those two things out because it was kind of a logical separation for us of like, let's put system stuff over here and user stuff over here. It really started from just the idea of like, you know, if everything's a bunch of containers and you can just do a one-liner to delete all containers, just say like Docker RMS and, you know, PSQA or whatever, and it wipes out all the containers. If you were to do something like that, you would just delete your entire OS. So that made sense to separate the two things. So once you have that, like what I was mentioning before, the Docker Compose stuff is if you have a Compose template, like here's an example, like etcd, and you put a Compose template that describes like etcd, you can just say like service enable etcd YAML, and then you have etcd. And so like what we're working on right now is kind of putting together a lot of these like Compose templates, like easily ready to use with a lot of very common Docker things, so like etcd or Flannel, Kubernetes, Blocker, Weave, a lot of the various Docker kind of ecosystem stuff. And you just want to make it, you know, just one liner, and you have it up and running. You don't have to, you know, give a lot of thought to it.
Darren, you're running that from inside the user Docker or the?
Well, so you're running inside of the console. So, so like when you log in, you run that control, like you're inside the console container at that time. And it just basically, so one of the things is like with Rancher, once it's up and running, there's no processes in memory that are like specific to RancherOS really. That was like one of the things we really wanted to go towards with like anything like we need, any type of functionality we need that would be like a daemon or whatever. It's like, let's try to figure out how to get Docker to do it in some fashion. Like, for example, like you might want cron, like we need cron for log rotate, which like we still don't have log rotate in here, but we'll be adding log rotate. But so if you're doing log rotate, you need that thing to run like every hour or something like that. So we're enhancing Docker. Docker has restart policies. You can say like, restart this container always. So it will, if it dies, it restarts it. But it's an exponential backup. But one of the things we put a PR in for Docker is just say like, hey, restart this container every 5 minutes. So something like that ends up being like a 4-minute cron. So we can actually do like log rotate by just saying, create a log rotate container, just say, restart it every hour. It will do its job and it will stop, and the Docker will restart in an hour. So a lot of things like, various things like that. Okay, so I'll get into like actually like demoing some of this stuff. Okay, so I'll make this bigger so hopefully you can see. Okay, so I guess we're going to Vagrant. Yeah. Okay, so the best thing to do if you want to get up and running with this is really Vagrant. So okay, so all of like our org on GitHub is RancherOS. So you can go to RancherOS. So this is like basically the the README for it. So if you want to get up and running with this, there's several approaches. We already have AMIs in Amazon, so you can just basically click on the AMI, and that actually launches the console, the Amazon console or whatever. We have an ISO, so you can download and just boot from the ISO. The next release, which will be released this week, has like far better support for bare metal. Because when we first released RancherOS, it was mostly geared towards virtual machines, because that was kind of like the easiest thing to get up and running. But we've had a huge amount of requests for bare metal, and actually like the idea of running containers on bare metal is actually pretty neat. There's a few things we can do that. So the next release will actually have far better support for bare metal. But the easiest way to get going is Vagrant. So we have this Vagrant project. So basically, you just do a git clone and then Vagrant up. Like I can show really quickly, but the catch here is that I just got this laptop. Like I'm running Linux here, and I just set this laptop up yesterday, and I was using like a bleeding edge Linux kernel, and VirtualBox just like halts on this thing. So if I actually run it, it'll destroy my machine. So we won't run it, but basically you just run like Vagrant up, and it'll end up launching like you do the normal. This one, okay, before it does anything. But so basically you just type Vagrant up, it'll come up, and then you type Vagrant SSH, and then you're in. So you can get RancherOS running really quickly. So if you just have Vagrant, so just go to vagrantup.com if you're not familiar with Vagrant. It's very easy to install and running. So what I'm going to do is I'm going to demo everything out of KVM. KVM is a little like more natural for me. It's like Linux virtualization thing. So I'll show you what it looks like. So basically, when we boot up, I'm just going to boot this from the ISO here. This is just a bunch of scripts I use for development. So when you boot up, basically, this boots up like relatively quick. I mean, it's not like super fast or anything, but you can see the different services coming up there. It says like creating UDEV, then there's a series of volumes. So like everything in RancherOS is built on Docker concepts. So Docker has a concept of volumes. So if we need to persist any state, it's actually a Docker volume. So we create all these various volumes to kind of maintain some state and stuff like that. So we have Cloud Init pre. So basically we support like a subset of Cloud Init right now. So that's basically how we get up and running in Amazon. and we're continually enhancing like the cloud init to add more stuff. Basically, we're leveraging a lot of code from CoreOS, a lot of stuff they did there, but we had to write a bunch of it from scratch, unfortunately. So, but we'll have support for, like we're running in Amazon, but like we just like tweeted today, like we have like RancherOS like, unofficially running in GCE, Azure, and DigitalOcean, like with full support for their metadata and everything. We're just basically need to create like official versions out there. But anyway, so we have cloud init. Networking, so it's like, since everything 100% is a container, like even like if you want to configure the networking for the box, like run DHCP, that's done in a container. NTP, syslog, user Docker, and then the console. Okay, so what I'm going to do, I'm going to SSH into this machine. SSH. Okay. So just a couple things. So like I can show you basically, like there's, once you're up and running, you know, it's just, okay, this is a clean machine. I run Docker PS. I have no containers running. So as I mentioned before, we have user Docker and system Docker. So Docker PS is user Docker. There's nothing running there. But if I do sudo system Docker PS, then I'm actually communicating with the system Docker. So basically the system Docker command is pretty much just like an alias for Docker, but we just know to point to a different socket. But you can see like, so those are some of the running containers. If I do a -a, there's actually a lot of other containers that like just started up, did something, and died. Okay, so like one of the questions always comes up with RancherOS is like, you know, it's like, well, what's your host operating system? What is it based on? And it's like, it's really not based on anything. The closest thing is actually a thing called build group. Because like some of our system containers, we make them super, super small. So there's this this tool called build group that's used for BusyBox environments to build basically Linux distributions for embedded environments. And so for our system containers that are running like syslog and NTP, like those ones are actually based off of a very small BusyBox environment, but those are in containers. But it's like, so what's on the host? There's really nothing. Like there's just nothing there. It's like there's not actually a host operating system. So the console itself, like, you know, if you log in, like, so here I'm like logging in, I can do an LS, I can run top, I can do these things. The console itself is actually a container too. So when I SSH into the system or I log in like through the console, like through Getty, that has to be a container. So to keep RancherOS small, by default the console is BusyBox based, which is like really not a great experience. Like most people, like the, you know, like the tools are all limited and stuff, like it gives you the basic stuff. But since it's a container, we can just swap it out with something else. And this is where we get into like system services and stuff. Is like you can just create basically like a service definition to override the container and pull in your own container instead of using ours. And so we actually pre-packaged one. So you can say Rancher control add-on enable Ubuntu console like that. Let me see add-on list. So you can see the console is enabled. Well, eventually we'll make this like dynamic, but right now you do have to reboot. So once I reboot, let's just give it a second to reboot. So then when it comes up, it's going to launch the Ubuntu console. So you can imagine someone can do, you know, you can create a Fedora one or a CentOS, or like whatever your favorite Linux distribution is. So yeah, so this is a Linux, so you can do like, or this is an Ubuntu console, so depackage and like various things. And so, you know, whatever console environment you want. So it's like what do you do with a console? It's like really most of the time you're just running like troubleshooting and stuff like that. And so it is nice to be able to like quickly install something like strace or, you know, various Linux tools. But the console itself is like, all it does is provide an environment for you to log in and do things. But everything else running is in a container. Oh. Okay, so we have the console here. So let me show you the only command like that you need to know for Rancher is like this one command called Rancher control, and this is kind of like our wrapper around everything for anything that's like Rancher specific. So it has like various like config, add-on, OS, TLS. So these are various things. So I'm just kind of going through these. So like config is basically how you can interact with the configuration of the system. Like, so what I can do is say like, if I say Rancher control config export. When I stand here, am I walking like?
No, you're good.
Okay.
Yep.
So you can see like the only thing that's really set right now is like the cloud init data source, which basically is reading from that file, and then that like add-on that I just enabled. This whole thing is documented. Like we're getting a docs, a nice docs web page put up, but like right now, it's documented in this on GitHub. But basically, like everything that you can configure in different ways. But if I run this command config export, I can do -- full, which dumps like the full, like the entire like kind of internal, all the internal settings of everything that's kind of in RancherOS. I'll go through this in like just a second. I'll show you some neat things about it. But so that's what the config one is, and then we have Rancher control OS. So basically, OS is how we manage upgrades. So I'll show you like how we actually do upgrades. So if I run sudo rancher control -v, I can see like the version of Rancher that I'm running here is 020. But when I did OS list, you can see 021 is that one's available, and there's actually a 030 RC1. So as we do releases, we publish this out there. When you do OS list, it's actually getting like some web server where we have a list of whatever's available. But if you want to upgrade, all you're going to do is just say upgrade. You can do -I if you want to pick a specific version, or if you just say upgrade, it'll just upgrade to the latest one. So we'll just do that. So you can say it's upgrading to 021, like that was whatever the latest is. Normally at this point, you would stage the template. So like the OS is actually packaged in a Docker image. Because the reality is all the OS really is a kernel and an initRD. And so we package those in a Docker image. So we just pull down the image, get the kernel and initRD, and update the grub configuration, and then we can reboot. So normally it would stage it would download right now, but I pre-staged it. It's just so faster. But so if I say continue, basically, so you can see like I have it set to kind of echo what the script's doing. You can see like this last line here, basically just copying the initRD and the kernel over into like the host OS, and so that's basically we just copy those things over. And then so we'll do a reboot. So let's give it a second. Okay, so let's give it a second. This version of the OS has a different version of the Ubuntu console, so it's pulling it. Luckily, it's not. This shouldn't take too long. So when you think about it, so it's like with Docker, you can pull down multiple images of different versions, and then you can launch containers from images of different versions. So the OS basically, it's like, okay, here's all my containers I need to be running the OS. When you switch to a new version, like a new version of the kernel and everything, like it might pull down new Docker containers if it needs newer versions, or it might be using the old ones, but it keeps all of that still in like where Docker stores, like it's the graph storage basically. It keeps all of those things stored, so it's like you can have multiple versions of Docker or RancherOS installed, and go back to them at any time with all the various different containers. This is mostly making sense. Okay. Let's see.
So does this mean that on the same, so let's say it's assumed we install this maybe to bare metal, you hold containers and everything just fine?
Yeah, everything's still there. So I'll show you like now that so that finally came up. If I do sudo rancher control, ctl version like that. Okay, 021. So I've upgraded to 021, but let's say for whatever reason I didn't like that. Okay. So I can easily just go and downgrade. So I just say I want to go back to 0.2.1. Everything's already pre-staged because it's already there. So this reboot should be much faster because it doesn't have to download anything. So basically I upgraded to 0.2.1. I didn't like it for whatever reason, and now I'm going back to 0.2.0. So I log in here, sudo range control version. So I just went back to the old version.
So when you think about the original image that you showed where you had all the different subsystems and you have the user Docker, that upgrade, did that affect those individual systems or just container for all the systems?
So there's a base set of containers that come with like the initRD, and so it's like, so let's say I'll have like version, like version 0.2.0 of the OS, and then it has like a base set of some of those containers, which will be like the 0.2.0 ones.
So whatever's packaged will affect.
Yeah, and then so when you upgrade to 0.2.1, it might come with some of the base 0.2.1. But like the 0.2.0 ones are still installed there, and then it just installs the 0.2.1 containers, and it'll bring those up, but it's a very small set. Like when you start bringing in more system services, like you want to run etcd and Sky DNS or Flocker, all these other things, they start bringing in a lot more components. Those things are completely isolated from the OS upgrade. Okay, so
That was actually my next question. So if you do install and configure etcd, then you will upgrade your OS, it's completely, you won't lose any configuration.
yeah, you don't lose anything. And so the thing is, like Linux has a very good. So it's like, what's the dangers that you're going to run into when you upgrade? It's most likely like the newer software has some bug in it. Like, but in terms of compatibility and stuff, like both Docker and Linux are doing like a good job on maintaining compatibility between versions. So it's like Linux API is very stable. Docker, like even surprisingly, even since I think Docker 0.6 or 0.8, they've been maintaining compatibility. Even though like this is an early project and they're a startup, they're really fast, they've actually maintained compatibility with their API and everything. So they've actually done a good job with that. And so it's like, because like from a development perspective, I'm constantly switching between different Docker versions, and I'm using like the same barlib Docker home that has all the stuff, and you can kind of seamlessly switch between all of them because they do a pretty good job about managing that. So you should be able to, within like a certain number of releases, like if you're running like some version of like RancherOS and then you roll back to one that was from 2 years ago, no problems. But like within like the last 2 releases, you'll be fine. The most the obvious case for rollback is you go forward, you don't like it, and you just go back. Okay, I'm gonna do it here is I'm gonna switch to a development version. So what I was showing you there was like 0.2.1 and 0.2.0, which is actually like our latest releases. But we're gonna be releasing one tomorrow or sometime this week. And I want to switch to that so I can show you some of the new features that we're doing there. Okay, so most of the stuff, like the stuff that we're doing now is because like we kind of have the base OS, we got most core services and stuff running. So now we're focusing on this idea of like system services and being able to easily bring in all these like things from the Docker ecosystem. So, okay. So once I log in here, so what I was talking about, you can describe the operating system or like whatever you have installed as a compose template. So in here, like we refactor the whole internals of everything to be based on compose. So if I do config export full here, okay, go down. So this is the full configuration for RancherOS. But once you get to this one key here for system containers, this is where it gets interesting. So everything after this is actually compose syntax. So this is like I was talking before, like various containers that are volumes. So that this is how one of the volumes one is. Like the all volumes is actually just a kind of a composition of other ones, like where it does volumes from these other. You see cloud init here, it's just running, the cloud init image with these labels. So one thing that we've done that's like a little unique is we use links to specify like the startup order. So we actually start with everything in parallel, and then so depending on, you just use links to say like kind of what's your dependencies. So the whole OS is actually defined. So there's a command one, here's our console, the network one. So it's like the whole OS it's just like one template that just defines the whole thing. It's like you can really just look at the OS as like you have a template that describes it, you have a series of containers that get pulled in, and then you have the kernel and Docker. That's it. So if you want to do something like that, let's see this works. Rancher control service list. Yeah, so what I already have in here, let me show you like.
So I do have a question for you on that. Sure. Does when your system starts up, so you upgrade to the new version of your, I guess I don't know the term you use, but upgrade to the new kernel or whatever, and then it says
new RancherOS version.
Yeah, new RancherOS version, and it says I know I need these things. Internally, is it using Docker Compose to get those new containers and update them, the system containers?
So we're not actually like the actual project Docker Compose. We're not actually using. Like we're just using the syntax because the way that we actually orchestrate, like start the containers, is actually quite different than the way Docker would do it. Like the Docker Compose would do it, because we care about like there's all these different things. It's like so imagine like I have a service named like I'm deploying a Apache, so I have a service named HTTP. So I have it configured one way. And so I start that service. Now I change the configuration of the service and I go and deploy it. Like, what's the right behavior? Because you already had a container of that same name with a different configuration. So it's like, how do you detect if it's changed or things like that? So there's all this behavior that's kind of specific to kind of making some assumptions because these are like system services and daemons and stuff about what's like the proper way to manage like updating these things or destroying them and stuff like that. So the logic ends up being very specific. The other one little issue we ran into with Compose is that it's quite large. Like if you go and download the binary, it's like 8 megabytes because what Compose is, it's a Python app and they compile it into like an EXE. So it's like a full Python runtime and everything. So the fact that it's not in Go makes it a little harder for us to use. So we ended up re-implementing a lot of the logic of Compose. Okay, so when I run like that rancher config command, the reality is under the hood, all it's really doing is just manipulating this one file, which is varlib rancher conf. It's just manipulating this one file. So what I've done here is I've added in one service for etcd. So you can see varlib rancher conf etcd. This is like what the Compose template for etcd would look like. Is basically, I mean, it's pretty straightforward, just running etcd with some listener arguments. And then you might add in some like environment, because it takes like it takes like a discovery token. So you like it's like discovery URLs, and I can't remember. So you might add in some parameters in there. But basically, so once you have this template, you can pretty much just say sudo rancher control or service enable, and then just put in that file, or not file, so the etcd one. And then that will just basically load in that etcd. So, or that Compose template for etcd. So you can look at, this can come in as part of like your cloud init. So you can imagine deploying like on Amazon in your cloud init, you just say, okay, load these 5 YAML files. Like this is a local file, but it could also just be some URL somewhere else. So load in these files, and then so now this thing becomes basically like installed all the containers you need. So when you start looking at some of the stuff that we're doing with Rancher and like these Compose templates, or RancherOS and the Compose templates, and then Rancher, our higher level orchestration, like how we're going to plug into some of this RancherOS stuff, it's almost like configuration management, like kind of reimagined in the context of containers, where like the units, all we really care about are containers. Okay, so right, so I can see like when I brought up this, like on this screen when I brought it up, you can see here like one of the services, because I already had it loaded in that template for etcd. It started up etcd, so if I just do like a regular PS, I've got etcd running there. Sudo system Docker PS, it's running right there. So so what we're doing is we're working on packaging up a lot of like things like Kubernetes, which are far more difficult to develop, like etcd and flannel, and then the Kubernetes server, the like minions and all this stuff. Like we're working on packaging it up like super nice. So you can just sit there, enable Kubernetes minion and or so any like specific questions about RancherOS? Okay. So let me see. So I'm trying to have fun.
45, 50 minutes.
Okay. So let me go into like there's no like specific things about RancherOS. I can start talking about our higher level thing, which is Rancher. Again, I probably don't have many slides. Let's see what I have slide-wise for this. Okay. So once you have, so basically once we have like RancherOS so one thing I have to make that really clear up front is like Rancher, the orchestration system, and RancherOS are not tightly coupled. Because we have tons of customers or people that we're working with that, they're already running Ubuntu or Red Hat or whatever, and they want to continue with that. So the way Rancher works is it just manages Docker. So anywhere that Docker runs, Rancher will work and it'll manage it. So of course it will manage RancherOS because it just is Docker. The only thing that we'll be doing over time is adding in specific hooks to detect that it is RancherOS and do a lot more smart things to manage the OS in addition to just like the user containers. But basically getting Rancher up and running is really easy. I mean, I'll just show you real quick, like what it takes to get this thing up and running. Log out of here. So basically, it's just Docker run. We're going to end up binding a port, Rancher server. Okay. Yeah. So basically, this will bring up the Rancher server.
So Rancher server is on the Docker registry now.
Yeah. It's been there from day one. So so that's really all. So the very first deployment, it usually takes like it's got to do a lot to kind of set up. It runs off of a database, and so kind of sets up the database and everything. So it takes like maybe a minute or two the very first time. Let it come up here. So this is actually like Rancher itself is actually a relatively massive code base thing. But so I just ran like I did Docker run, got Rancher up. So basically once that's up and running, then you get this UI here. So the very first thing you need to do is you need to register a host in order for us to manage anything. So if you click the add host here, basically, here, I'm going to switch over to a different one that has, this is like our latest version. Because what I have on my desktop is kind of like the latest released version, but this is the latest development version. So you can see, so when you go and you say add host, like you can see already we have like DigitalOcean and Amazon EC2 in here. Basically, we're just wrapping Docker machine. So we'll add actually every single Docker machine provider in there. So you can just go and get a host from wherever. And of course, like, we're working to make Docker machines work really well with RancherOS, so you can get RancherOS. But right now, Docker machine is actually largely based off of Ubuntu.
What if you want to add an existing host?
Yeah, so that's if you want to deploy a new one, but if you have an existing host, then there's this custom one.
Okay.
And so this is actually the primary use, this is actually the majority of what people do is this one. And is basically just copy this big long command. once you have that big long command, then you can you just copy paste that and put it into your host, and then it will register. And you'll pull down the agent, and you can see in here it has like basically a unique key that's specific to this account. Because like in Rancher, what you can do is you can create. I might actually be able to set this up here. Contract. So there's. Let me see. Let me see if this is going to take forever.
So is this,
Yeah.
is this a little bit like Docker Swarm where you're pulling in a few hosts so you can manage them? I mean,
Well, yeah, so it's kind of like, this is the kind of the super level of this. It's like, I have a bunch of hosts. So basically what the first thing you're doing is basically you're registering hosts to accounts. So, or accounts or projects. So you can create a project in Rancher and then register hosts with it. And then multiple people can log in, like we use GitHub authentication right now. And very shortly we'll be adding like AD and LDAP. But so multiple users can log in and share hosts, basically resources through projects. So once I have my hosts, now I want to start deploying things on them. So at that point you can start assembling, creating swarms. And so the swarm stuff, so a lot of the stuff in Rancher is we've been working pretty hard over the last 3 months, and most of the stuff is really close to being done. So you'll see over the next month a lot of these features land. But so the swarm stuff, basically what you'll be able to do is you go in there and you say, okay, I want to create a new swarm, like a cluster, add these hosts to it, and then we'll deploy the swarm agents for you instead of the discovery and the TLS, and basically just kind of give you the endpoint of okay, this is the Docker host, and here's your certificates. You just copy those, and then now you can run Docker run against the swarm. But some of the more interesting things that we're doing is when you deploy things, let's give this some time to download, because I want to show you kind of the project stuff, how it works. But what you see on this screen here, so we do cross-host networking. Basically, we can do cross-server links, and basically we create our own overlay network. So these 3 nodes here are running out on Google Cloud. But basically, they could be running anywhere. A lot of times when we do this demo, we'll deploy some in Google and DigitalOcean and SoftLayer, so you can kind of show that it runs across cloud is fine. But you can see this machine here, that's the IP, 146 something. This is the IP of this other one. But each one of these containers, we give it an IP that's on the overlay network, and we manage this. And so you can see okay, I have this one container running here. Oops, I didn't click that. We have this one container running here. I can go and execute a shell on it, do whatever. But so that's running on this one host. You can see the IP is 10.42.49.245. So I can after that 49.245. So if I go and I launch a shell on this other Ubuntu container here, so 49.245. Hopefully this works. Maybe not. Go to cluster server. I don't know what that one is. We're just deploying container over here. Okay. 49.245. Okay. Ping 10.42. 49.245. If everything works, yeah. Okay, so you can see. So from that one container and pinging the other one, this is going over our own overlay network. And basically, this is all IPsec based. It's all encrypted and everything, running over IPsec tunnels. And so we manage all that. So one of the interesting things is when you go through Swarm and you deploy things, you can actually just put a label, an environment variable or a label that says I want Rancher networking, and we'll hook up the networking for you. We detect the containers running and hook up the networking.
So do you have anybody that you personally have anybody that is using Rancher to host a website, a web front end that uses a bunch of different APIs like microservices, and then they'll hit a bunch of microservices running on Docker containers through Rancher?
Well, yeah, I mean that's almost a primary use case of what people do with Docker.
That's kind of cool.
So I'll show you we have this thing finished. Let me start up this again. I want to show you the project stuff. But so we're working on a lot of the service discovery aspects. Like that's like kind of like the more major work, and we'll be at a conference next week where we'll be demoing this, the kind of the service discovery aspect stuff. Because basically what you can do is you can say like, okay, deploy a container, and you put these labels and say like this container provides service foo, this container requires service foo. So for the container that requires that service foo, no matter where it is on whatever host, like we detect it, we know it requires that service, we set up a DNS name for that container. And so in the container, you can just say like ping foo, and you'll get to foo, and it goes to wherever it needs to. But that works fine for like a one-to-one communication, or you can do a one-to-many. We'll serve up like multiple DNS records. But there's also like a load balancing use case, and so we have a load balancer. Like what we currently have in the kind of in the alpha product right now is like the simple load balancer, which is like just lets you set it up manually. But like when we do all the service discovery stuff, it'll start being like more dynamic and automatic. Like you can see here with what we currently have is you can go and say add load balancer. You can give it a name and description if you want, but basically you can choose which host you want running on. So you're like, okay, like I want this to be running on these two hosts, and then I want it to be load balancing, this container. It'd be better if I had better names on this container. But say maybe something else that's not even a container, and you're just like, I just want to load balance, this IP or whatever.
Is it just load balancing all requests, all ports? Or I mean, what?
Oh, so then you have basically you get down here to the configuration of the ports. So you say like I want to load balance port 123, or let's say public 80 goes to private 123, like TCP or HTTP. We'll end up adding HTTPS and SSL to do SSL termination, and then you can configure like what the health checks are. So if this thing goes like, because you put in a check URL of something like ping for your service, and so we'll hit that on an interval, and if it doesn't return good, then if we pull it out of the load balancer.
You may have answered this already. Are you using like HA proxy?
Yeah, I know that's just HA proxy. Okay. And then we probably might like do something with Nginx too, but for the most part, there's like very little reason to like just. I mean, HA proxy is pretty darn good at this point. Yeah. So yeah, and we have a lot of experience in running HA proxy from the cloud stuff we've done. So then you can pick stickiness and everything. So this is like a very kind of a manual. It's here's my targets, here's my load balancer on this. And so you can just set this up. So if you deploy a new container, basically you're going to add that container to the load balancer, or you can remove containers from the load balancer. But what we're doing with the service discovery is you can just say like, okay, I have this load balancer and I want to load balance any container which provides service foo. So when you deploy a container, you say it provides foo, we detect it and add it to the load balancer. So you can do this all dynamically. So then you can use like one of the things that's like really important to us from like a Rancher perspective is like, we know we're not the center of the world and we don't want to be, is that a lot of these like orchestration systems, and we actually ran into this in the past with CloudStack when we wrote CloudStack, was if somebody goes through the orchestration system, everything's fine. But if someone comes like behind the scenes and changes things, it kind of screws everything up. So let's say like, I'm running like Kubernetes or something, and I want to go onto the host and just say like Docker run and create a container. Like Kubernetes has no knowledge of that. It doesn't know what it is. It doesn't know if it's in a pod or whatever. It just doesn't, like it can't manage that. Like, that's just like an orphan thing out there. But what we wanted to do with Rancher was we wanted to enable that use case, because we know people want to use Ansible or Puppet or Chef, or maybe they have like a different orchestration system. Like they actually like there's some things they want from Rancher, but they still want to use Kubernetes. Like something like that might make sense. And so what we do, like this is some of the features that we're working on, is that when a container, it's like if you log in, you say like Docker run, we detect that that container is new, and then we do all the orchestration around it, like in an eventually consistent fashion. So we'll do things like set up the service discovery, the load balancing, and the networking, and if there's any storage stuff we need for it.
Are you listening to like Docker events? Is that how you're
Yeah, right now it's Docker events, but we're doing a lot of work to like, there's been a lot of work on like trying to get plugins that actually do like blocking operations. Because the big problem with Docker events right now is like two problems. One, it's not blocking, so it's like you just know like, oh, that container started, and then you can try to quickly do something. So what we do right now is like if you start the container, like we need to assign different IP to get on the overlay network. So basically we go through the orchestration and it pops up within like a half a second, which is actually too slow for a lot of applications. So that's one problem, is it's not blocking. The second is there's no way to halt. Like you can't say like, oh, this fit, and then just stop Docker from starting. So there's a lot of work to make that possible, and hopefully it gets into Docker 1.7, the plugin. There's quite a few like parties involved in doing that. But yeah, so we're just basically, like the whole way Rancher works in general is it's just an eventually consistent system. So we have all these things, so it's kind of like we have an orchestration state, we have something going on in Docker, we have swarm agents, we have users who screw with things. Eventually this all kind of gets to a consistency. We just kind of manage it all. Oh yeah, so I wanted to show, let me go back to here, we can see if we can get this running, because I want to show you like the project support, because it's kind of, because so people can come in and like manage their own. So what we have support for is basically, so you go and you configure the access control. Like right now we just have support for GitHub, we'll be adding more, but it's like it's relatively easy to get up and running. We have like the instructions here, it just says click here, that ends up popping open this page. And then it just says register a new application, and you're gonna need this URL. So you go over here, register an application, I'm gonna call it my app. I'll give it this URL, which is like localhost. This actually works localhost. I go back to the instructions, it says add some description, anything you like, and then add this URL here for the authorization callback. So put that one there. So we say register application. This gives you two things, the client ID. So we paste in the client ID, and then it also gives you a client secret. And we just paste that in. And then we say authenticate. This will do the OAuth authentication. If everything is good, okay, now it's set up. So now we're just enabled like GitHub authentication for the site. So you can run this out like on the public internet, and not worry about people like whatever hacking it or something. Well, the next thing hacking. So but once you have that, basically you can go and you can create projects. And it's kind of funny. Like we did this, we added support for projects and stuff. And so like we did all this. We had to GitHub support for like we added support for projects or whatever. We kind of got in front of a couple of users and then found out it's like really confusing. So we're actually revamping all this to make it like much more obvious what's going on. But basically you can go and you can add projects and say like, okay, my project here, and I can authorize it and say like, okay, I want this for the Rancher Labs organization. So now anybody who logs in from Rancher Labs, they'll see a project over here, and so they can go in and add hosts from that project. So we separate out all the resources and everything. So this is like a kind of a big feature for like people, multiple teams. Because reality is like you have one company, most of the time you have multiple operations teams managing different resources. Let me see this. So virtual machine. Container. Yeah, so I'm just going through some specific things I want to talk about. So we have the container networking part, we have the load balancer, I talked about that. The last thing is storage. The reality is right now in the Docker world, there's not a huge demand for like persistent storage. Most people are putting ephemeral workloads. That doesn't mean that Docker can't handle persistent workloads. It's really what it is, it's just people's comfort level. It's like, this is a new technology, so what's the first thing I'm gonna run on it? Obviously not my database. Like I'm gonna run my web servers and things like that are more ephemeral. But even though like some of the storage requirements are a little farther off, it's obviously they're coming. So we're working on some technologies that are a little farther down the line. In the short term, in about like a month from now, or actually pretty soon, we'll have support for just snapshotting Docker volumes. So you have a volume, you write data to it, we get snapshotted, and then do incremental backups to like S3. And then you can restore it from that backup. That gives you basically like, the problem is like when you run persistent storage, there's very few cloud, like, you know, you can get like EBS. There's a couple of clouds that will give you like persistent storage, but some of them don't. So the reality is, like, kind of dependent on the infrastructure services that are available in the cloud, you can kind of get tied to a cloud, even though your containers are completely portable. And so that's just one thing in general that we're trying to address at Rancher, like building up these cloud portable infrastructure services. So like EBS is one of those things. It's like, you can get EBS from Amazon, but not from DigitalOcean. But if I could get reliable, replicated, mirrored storage anywhere, that would be great. And so we're actually building technologies around that. But in the short term, we're just focusing on like fast incremental snapshots, because then at least you can say, like, take a snapshot every 5 to 10 minutes, and then at most you'll lose like 5 to 10 minutes of data. Let's see. Yeah, so in general, I mean, this is all basically up on our GitHub page. This is all completely open source. We'll continue to support everything open source. As I've said before, it's pretty much all alpha. So, you know, there's a good amount of bugs, but we're mostly looking for people to just try it and get feedback of like whether or not this feature makes sense, or like you try it and you go like, it would be really cool if I could do this one thing. You know, we're really looking for things like that. You know, for the most part, like, we do have some people like running production workloads on it, even though like it doesn't make us like really comfortable. But there are people actually in production work, so it does actually, you know, it works very reliably. Yeah, I think that's about it. Any questions, comments?
So it's open source. What license did you use?
Apache. Yeah, that's what we've done open source projects in the past with ASL. Seems to be very business friendly.
What about partnerships? Like, do you have it, like, some of your existing partnerships you working with directly?
I mean, I can't say like there's no like really official partners. You know, there's no I don't know, like kind of like the Docker ecosystem right now is not really kind of. It's just, oh, okay. It doesn't really make sense for people to have like kind of like official partners quite yet. But basically, we're working very closely with like Docker, and then like Flocker and some of those guys. But then like Google and Microsoft. I think most of the like major, we have connections with like most everyone.
This is because a lot of the problems like you're addressing are like right on our roadmap for what we're trying to do. We're trying to get it's an omni-channel retail platform.
Yeah.
That we want it to be cloud agnostic.
Yeah.
And so this is right up the alley that we're trying to do. But, it'd be interesting to see who you guys are partnering with a little bit, and see what they're doing at the same time.
Yeah. So we're so basically, I mean, I'll tell you, like, even like the company, we haven't even like really officially announced like our funding and stuff like that. But we are working with quite a few people, so we'll have some like major announcements that will come out. People we're working with and things, but can't say too much.
No, I get it.
Yeah.
I mean,
But we're
talk a little bit.
Yeah, we're well funded. We have a pretty darn good team.
So I saw you add hosts in this UI and whatnot, but is there like an API where you can add hosts and do things more?
Yeah. So this is an interesting thing about our API, that like we don't. Let's see. I'm gonna turn off access control so I don't deal with keys. Okay, so like in general, like at Rancher, we really want to be well aligned with Docker. We don't want to wrap Docker. We really want to support the kind of the native Docker interfaces and be able to like pull from the whole Docker community and ecosystem and all that. So the ways that like we're really pushing that we want people to interface with Rancher is like, running Docker from the command line, running through Swarm, running through closed templates, things like that. So that's what we mostly talk about. But there are things outside the scope of Docker that you do need to do, like interact with Rancher, and so we do actually have a full API for this. So basically, I'll show you here's the API is actually it's pretty the way it works and everything is well documented, the structure, the format, how to interact with it. We have Python and Go bindings, and there's a command line tool. But basically, like you can click here, like click around, and you can see like internally, like if I want to create a container, like these are all the various fields you can put in. You say like show request, it will give you the curl command, and then like that's the whole request it will send, and then send it. But you can see here, it's like it was missing some field that I needed. Actually, oh, whatever. So we have a full API for all this stuff, so you can script all this and everything. So what most people do though is like for adding hosts, to be honest, is because for hosts, you need to put this command. So basically, you just put it in your cloud in it. So like when you deploy an Amazon instance, it just runs this on startup, and the host automatically registers. So that's usually what people do. And so what we'll be doing is like we'll be adding support for RancherOS. So like as I showed you before, like RancherOS has that Rancher YAML, which basically describes the whole state of the operating system. So you'll be able to essentially manage the Rancher YAML from Rancher. So when a node comes up, you can say like over here, like it's like you can just define like what's the configuration of the node. So like if you have 100 servers, you just go like, okay, these 4, that's an etcd cluster now. Like these ones over here are Panamax clusters. So you just kind of you can just do that all through essentially through Rancher.
So that health check you were showing before, is that like when it finds a node is unhealthy, it takes it out of the the pool of load balance?
Yeah.
Does it also just bring a new one back up? Or?
No, so like the one that we have right now for like this load balancer, like what we currently have right now is like it's kind of static. It's like here's my targets. And if it's unhealthy, it'll pull it out, but now you're like in a degraded fashion. So what we'll be adding with like the service discovery part is basically you'll define like a compose template and say, okay, load balance this this web tier, which is like here's like are you familiar with auto scaling groups in Amazon? Okay, so like basically what you do is you say like, okay, I want like 5 of these, and here's the template of how to deploy it. Like here's it should be this image and these parameters or whatever. So with the compose support, you can say, okay, load balance this tier, and I want like 5 of them. And then so like if one of them goes down and it's not healthy anymore, we'll spin up another one, and then it automatically gets load balanced. So so that's kind of like the next phase, and so that's the stuff that will come over like the next month or 2. So it's like the beta time frame is like so so this is all alpha. Basically, the beta like is within 2 months from now. Like if you talk to anyone in the Docker ecosystem, like everyone is like the hard stop for everyone is DockerCon, which is in June. So I can pretty much guarantee we'll have a beta by DockerCon because everyone wants to announce something then. So so within the next 2 months, you'll see a significant amount of stuff.
So are you like contracting support and training and stuff like that? So all this is just open source?
Yeah, no, I mean, not right now. I mean, like the product's so early, but like we're not even necessarily even selling it. I mean, we're like talking to a lot of customers, people are deploying it, but like, actual real money, not even like really having those discussions, but you guys want to talk to we have our sales team or whatever.
Yeah,
You can talk to them. Yeah. Yeah, I don't know. I'm the technical guy. So.
What's the best way to hear about updates? Is that just through you guys' blog or?
Well, I think if you go to so Rancher.com, there's probably like subscribe to a mail newsletter type thing, I'm sure. Yeah, so you can subscribe there if you want to get updates. But the thing, everything's going on GitHub. So you subscribe to basically RancherOS, and basically the other one is RancherIO Rancher. So if you watch these, you'll see everything that's going on, all the commits and issues and pull requests and stuff. And so you can see, like on Rancher itself, actually Rancher is kind of like a meta repo. The actual real development is in this other project called Cattle. But we basically, like if you look at, let's see, it doesn't look that. I mean, we've got like a good amount, because we've got, I don't know, maybe like 10 developers all working on this. There's quite a bit going on, like a lot of activity on it. Yeah.
So 6 o'clock, you're not visiting?
What?
Are you visiting?
Yeah, I'm from Phoenix actually. So
That's right, you guys don't do that.
Yeah, we don't do daylight savings. But so the company, like our company, RancherOS, is based out of Cupertino. So we're split between Cupertino and Phoenix, and so there's a small team of us out in Phoenix, and then the rest of like the co-founders and everyone else is in Cupertino. So the Cupertinos is basically our headquarters, but not out there. But because the fact we don't respect daylight savings, we end up for the same time right now, California and Arizona.
Kind of convenient for you guys then.
Yeah, and then we'll for half the year.
Yeah, it's retail.
And then the other half of the year change.
It's just confusing.
Yeah, we'll try dealing with international. It gets really confusing.
Yeah, I lived in Tucson for 3 years.
Yeah. Have it. Yeah. That's it.
Thank you
Well,
very
I
much.
appreciate it.
Yeah.
Thanks to everyone for braving the snow. Darren actually flew in today and is flying out tonight, so we really appreciate him coming in. We're hoping for a great turnout, but I think this is going to plant some seeds in a lot of companies that are going to be interested in using this. So, yeah. Anyway, spread the word, guys. Hopefully, we're going to keep building this. We got like 60 members now, but need more of them to come each month. So, and let me know. Like, hit me up. Dustin last time sent me some good ideas for future meetups that you'd like to see. But if you have other things that you like, things you're trying to solve in your companies right now, like problems that you are hitting immediately and you want to have a meetup about it and have somebody present, like there's enough knowledge within the community that, whatever problems you're having, we can probably, have somebody talk about them for a little bit, even if it's just, hey, this is what I've tried and it didn't work. So just hit me up on Meetup. So if you have any ideas, and thanks for coming out. Everybody grab some pizza if there's any. I'm sure there's a lot left. So those who brave the snow get to take pizza home as a prize. So thanks again, guys.
Question for you.
Sure.
I'm